Okay, general relativity step by step. We spent quite a bit of time here converting between EX and EY. Between EX and EY and EH and E theta. We had the X and Y system, and we've got the H and theta system, and we had EX and EY, and here we had EH and E theta, and we could convert backwards and forwards using those rules. What I'm going to do now is I'm going to consider the general case. I'm going to consider a coordinate system. We're going to have two coordinate systems here. This one is going to be the unbarred system up to xn, no bars. These are not these are superscripts, they're not powers. It's not x to the power n, it's the nth sequence. So you normally consider x, y and z, I guess, but we're just going to call them x1, x2, x3. And I'm just going to keep my options open on this n here. I'm just going to leave, as much as anything, I'm indicating that there's a finite number of them. And there's another coordinate system which I'm going to call x bar 1, x bar 2, all the way up to x bar n. And we can convert from one to the other. There's some functional relationship between these two guys. So what do the basis vectors look like? Well, E1 is di p by di x1, and so on up to En, oh that should be what it is, equals di p di xn, and here we've got E1 bar. See, the notation gets messy. I've got a symbol E with a thing on top of it, a thing below it, and a superscript. Equals di p by di x bar 1 all the way up to En. That's got a bar on top of it, which equals di p by di x bar n. So we've got a whole system of these things, and of course n equals 4 in relativity because we've got 3 space and 1 time dimensions, but I'm just going to keep my options open. It makes things simpler. So how do I convert between these two things? Well, let's just say I've got EI equals di p by di xi, and here it's understood that I equals 1, 2, up to n, any value. EI equals di p di xi, and I want to express it in terms of the barred coordinate system. So of course what I do is I just decompose my p into bar xi plus, I'll write out the first two terms, di x bar 2 di xi plus dot dot dot, and the last term, di p by di x bar n, di x bar n, di xi. So what I'm doing, I'm observing the fact that p has got two ways to be expressed. P, the point P, can be expressed in terms of the xi's or the x bars. It can be expressed in the unbarred coordinate system or the barred coordinate system. And if I want to think about it in the barred coordinate system, then I need to decompose all the dependencies of P one by one like this. Now then again, so I've got EI equals this thing here. And of course, this thing here is just equal to E1 bar di x bar 1 di xi plus E bar 2, because this is di p di x bar 2, di x bar 2 di xi plus all the way along to En bar di x bar n di xi equals sum j equals 1 to n E j bar di x bar j by di xi E I. Now, of course, there are easier ways to write this, and I'll introduce Einstein's summation convention at a later time, but it gets a bit confusing at the moment. I just want to do things one step at a time. I'm just going to color code a couple of things. I'm going to color code a couple of things. I'm just going to take a red pen here, and I'm going to replace, oops, I didn't mean to do that. I'm going to go back to black. That's an E. Now I'm going to go to red, which is there. That I there in red is the same I as that one there. It's because when I differentiate with respect to the xi without the bar, that crops up here and here and here. And you can see that that I there appears here and here and here and here, and in the general case is here. I'm also going to colour in, see if I can do this. Oh, I mean to do that. E, and then that's a vector, and I'm going to switch to blue now, see if I can do this without cocking it up. That's a J in blue, and I want this superscript to be in blue as well. Actually, and this one should be blue, I guess. J equals 1. I guess it doesn't matter what about that then, thing there. So it's summed, oops, go back to black. It is summed over J. In the same way that when we had H and theta, we had a complicated intertangled dependence between H and theta and X and Y. Here we've got a complicated tangled dependence between the two coordinate systems, the x1 up to xn system and the x bar 1 up to x bar n system. So this here is a nice, succinct, coherent way of linking two sets of basis vectors defined on the same space but with two different coordinate systems. Okay, I'm going to leave it there.